we present GraphFill. GraphFill is a graph neural network-based deep learning framework that estimates plausible coarser information for inpainting, which a refined network then refines. Suppose a portion of the image is masked using a binary mask. The task of image inpainting is to fill in the masked region with plausible information. These are the final inpainting results obtained by the proposed approach. We first create a pyramidal graph from the image, with varying numbers of superpixels in each level, determined using the simple linear clustering technique. Likewise, we break down a masked image into a pyramidal graph, marking superpixels from the masked area as unknown using an indicator matrix. We construct pyramidal graph G and G' from these superpixels, where each superpixels at a pyramid level acts as node in the graph. We calculate adjacency matrix of the graph by estimating neighbors of a superpixel in image space. Graph G and G' are utilized as training pairs for GraphFill. The role of the GraphFill network is to predict the values of unknown graph nodes with G' as input. Starting with a masked image, we initially build its pyramidal graph. The GraphFill network receives the pyramidal graph as input and predicts the coarse inpainted output. In the end, we utilize a lightweight refined network to enhance the coarse inpainting, producing the final output. Beginning with a 0th pyramid-level graph comprising a minimal number of nodes, we use the coarse net to predict the values of unknown nodes. The coarse net comprises multiple gated aggregation blocks that use the adjacency matrix for gated aggregation among neighboring nodes. Its output, the inpainted graph, is translated back to image space with graph-to-image layer, resulting in the coarse inpainted image. The coarse inpainted image serves to update graph nodes in the next pyramid level. This is accomplished through an image-to-graph layer, followed by a merger operation. The graph filling process iterates through all pyramid levels until completion. The output at the last pyramid level represents the final coarse inpainted output of the GraphFill network. The coarse output from GraphFill is then refined by refined network to obtain final inpainted output. The refined network is a lightweight shallow pix-to-pix baseline network. In this slide, we present results obtained by our approach on the Places dataset, along with state-of-the-art methods. The results on CelebA dataset are shown along with other state-of-the-art methods. Our proposed network achieves competitive results even with a substantially lower number of learnable parameters than heavyweight existing methods. With TF-Lite model size of 4.6 megabytes, the model takes about 13 milliseconds to load, and the entire inference process takes about 10 milliseconds on a Samsung Galaxy S23 mobile device. We demonstrates the robustness of GraphFill inpainting as we progressively enlarge the masked region area in comparison with existing methods. GraphFill excels in preserving global context, enabling the refined network to generate visually plausible inpainting results. Since undesired objects occupy a smaller region of the overall image size, We use an adaptive cropping approach that crops the input image around the masked area, as illustrated in the figure. We constrain the maximum cropping around the masked region to ensure the image size is not reduced below a certain threshold. The RPG approach lowers computational complexity in graph construction and inference time, all while upholding Inpainting performance. This allows for efficient handling of high-resolution image Inpainting. Here, we show results on the samples of Davis dataset. Finally, we present quantitative results of our approach compared with other works. Our approach obtains competitive results when compared with heavyweight models and outperforms existing lightweight models. Thank you.